Welcome to this explainer on ALB versus API Gateway. Imagine this. Your brand new mobile app finally gets featured on the App Store. It's the exact moment you've been waiting for. Thousands of enthusiastic users hit your backend all at once. The traffic is absolutely massive, just pouring in way faster than you can even track.
But it's not just volume you're dealing with here. You've got malicious bots out there trying to scrape your data. You've got impatient users aggressively spamming the refresh button over and over again. And within minutes, your entire system crashes. And here's the truly frustrating part. It failed not because you didn't have enough servers spun up. It failed because you didn't control how traffic entered your system in the first place.
This brings us to the ultimate traffic cop problem. You have clients on one side, browsers, mobile apps, maybe other services, and your backend compute on the other side. You need something intelligent in the middle to catch that incoming traffic, inspect what it actually is, and carefully route it.
AWS gives us two heavyweights to solve this exact architectural challenge: the Application Load Balancer, or ALB, and Amazon API Gateway. Both of these powerful services can route HTTP traffic. Both of them can trigger your underlying compute services. And honestly, this overlap confuses almost everyone studying for the AWS Solutions Architect exam. Now, just a quick heads up as your guide here. While the official exam guide lists these load balancing and API management tools under Domain 3 high-performing architectures, the specific feature comparisons I'm hearing today come from real-world AWS documentation outside of that specific blueprint, so you'll want to verify the exact specs independently. Let's break this down to its absolute simplest form, starting with the Application Load Balancer.
An ALB is exactly what it sounds like. It simply balances the load across your resources. It sits right at layer 7 of the OSI model, looks at the incoming HTTP or HTTPS request, and routes it to the right target. That is its core job. Think of the ALB like a highly efficient restaurant host. You walk through the front door, and the host looks at you, asks, "Do you want the bar or a table?" and then points you to the right place based on your answer. That is really all it does. It doesn't step into the kitchen and cook your food. It doesn't stop you from eating too fast or ordering too much. It just gets you to the right server, the right container, or the right Lambda function based purely on the URL path you requested.
What happens if you don't use it? Well, one single server gets 99% of the traffic and completely dies from the overwhelming load, while the rest of your expensive servers sit completely idle. The trade-off for using one? ALB is incredibly fast. It is extremely cheap at massive scale. But it is just a router. Now let's look at Amazon API Gateway.
API Gateway is not just a router. It is a full-blown front door, a highly trained security guard, and a sophisticated traffic manager all combined into a single managed service. It can do what the ALB does in terms of directing traffic, but it adds massive, crucial intelligence to the equation. It can aggressively throttle requests so a single rogue user doesn't spam your backend into oblivion. It can mathematically validate complex JSON payloads before they ever have the chance to reach your underlying servers. It can even manage dedicated API keys for your premium paying users.
Think about that for a second. With an ALB, a badly formatted, potentially harmful request hits your backend compute before it finally gets rejected. With API Gateway, that bad request is killed immediately at the door. Your backend never even wakes up. You save compute, you save money, and you maintain absolute security.
Oh, now I get it. So here is the mental model to remember. ALB is the friendly host routing traffic. API Gateway is the bouncer, checking IDs, enforcing the house rules, and stopping fights before they ever spill into the main room.
Now pay attention, because here is where people completely fail this concept. They see a serverless architecture diagram using AWS Lambda, and they automatically assume they must use API Gateway as the trigger. You don't. An application load balancer can directly trigger a Lambda function too. It's a massive misconception that costs people points on exams and money in real-world architecture.
So when do you actually use each? This is the million-dollar real-world decision. If you are building an internal microservice or a massive-scale web application where every single millisecond counts, and you just need to spray high-volume HTTP traffic across a massive fleet of EC2 instances or containers, you use an ALB. It handles incredibly massive throughput and costs a tiny fraction of what API Gateway charges. But if you are exposing a public API to third-party developers, you absolutely need API Gateway. You need to hand out API keys. You need to create usage plans to charge customers based on how many API calls they make. You need strict, enforceable per-user throttling to protect your platform.
Now imagine this disastrous scenario in your system. You put a simple ALB in front of a heavily used public API.
A malicious user, or even just a badly coded client, writes a script that spams your endpoint 10,000 times a second. Your ALB happily, blindly routes every single one of those 10,000 requests directly to your backend. Your backend frantically scales up, processes the absolute junk, and at the end of the month, your AWS bill absolutely explodes. It's a devastating financial hit. If you had used API Gateway instead, it would have recognized the abuse and throttled them instantly right at the door.
Now here's the exact trap you will see on the exam. The scenario will describe a company migrating a standard web application. They'll say they want to route HTTP traffic to a fleet of backend servers. But, hidden quietly in the second paragraph, it will mention they need to manage API keys or throttle requests by user tier. If you just read route HTTP traffic and hastily pick application load balancer, you fail the question. ALB does not support API keys, ALB does not support per user throttling. The moment you see the specific words, API keys, throttling, usage plans, or payload validation, you immediately pick Amazon API Gateway.
Oh, now I get it. It ultimately comes down to this. The choice isn't about where the traffic goes. It's about how much control you need over the traffic itself before it's allowed inside. Let's lock this in one final time. ALB routes traffic efficiently at massive scale for cheap. API Gateway manages, secures, and monetizes public-facing APIs. Use ALB for high throughput, internal routing, or simple web apps where speed is the only metric. Use API Gateway for API keys, throttling, and full API lifecycle management. Both can trigger compute services, but API Gateway always protects your backend better.
Which leaves us with this final thought. Is your backend currently paying the price for a missing bouncer? Final warning. If your architectural scenario demands usage plans or API monetization, ALB is a dangerous trap. Pick API Gateway. Master this crucial difference, and you completely control the traffic.